Today we're going to be starting Module 12, Lesson 3, where we are going to begin our lesson by building a tetrahedron out of an envelope. But envelopes are expensive. Copier paper, not so much. So before you can build your tetrahedron out of an envelope, then we have to start off by building our envelope. And to do that, I have taken and printed out some templates where you will get to use one or the other. It does not matter which one you use. Everybody's going to use one or the other to create the envelope. Now, you may be wondering, what is a tetrahedron? Well, a tetrahedron is this. It is a four-sided polygon. Poly means many, gon means side, so a polygon is a many-sided figure. So it is a four-sided polygon, and all of the sides are triangles. And this one I created by using the bottom envelope. Now we are going to take and work together, and I'm going to show you how to take and make a tetrahedron using the top envelope. So I've already cut out that frame, and I'm going to take and start off by folding it across the lines, the dotted lines, just like that. And I'm going to fold this one in. I'm going to fold this one in. And I'm going to fold this one in. And from here, I'm going to get some tape. And I'm going to start taping things closed, because we have to have a closed envelope in order for this to work. So I'm going to put some tape across here. And some tape across here. I'm going to fold my top down. And I'm going to take and put some tape for this one across here. Now, it's really important that you don't take and tape it to the inside of the envelope. You're not doing that. You're taping the flaps together, but you're not actually taping it to the inside of the envelope. Now, tape doesn't write on very well, so I'm going to take and flip my envelope over for the next part of this, and then I'm going to use a straight edge, and I'm going to draw some lines that are going to go diagonal across my envelope. Like that. And like that. And I'm going to fold across those diagonals. I'm going to fold both directions because I want this paper to be really loose and easy to work with. So I got to fold it that way. And I'm going to take and I'm going to come back. I'm going to fold it the other direction across that same diagonal. Just like that. And then I'm going to take the other diagonal. I'm going to fold across it. Just like this. I'm going to fold it the other way across the same diagonal so that it's just like that. And then I'm going to open it all back up. We good so far? Now I'm going to take my scissors and I'm going to cut one of the large triangles out. So I'm going to cut across here just like that, and I'm going to cut across here just like that. And this piece is garbage. We're just going to take and discard it completely. Now comes the fun part. The next thing we're going to do, and this is a little challenging, we're going to open up our envelope so it's like that, and I'm going to fold this corner and tuck it in to the bottom inside of the envelope right there. So I'm going to fold it, so I'm going to take and tuck it in. And as I do that, I'm folding up along the bottom just like that to make my tetrahedron. Now let me show you that again. I've got the envelope kind of opened up like that, this corner goes inside and down there. So we're going to take, once again, fold it up, and we're going to, as we're doing it, going to take and tuck in, and then once it's tucked in, we're going to tape up our tetrahedron right here and right here. And now I'm going to make a nice crisp edge along this side right there. And you can see I have a tetrahedron. It's not a regular tetrahedron where all the sides would be congruent, but it is still a tetrahedron where you've got 4 triangular pieces that come together to form a polygon, a polyhedron. Now, where you did all of this so we could learn some vocabulary terms. The first vocabulary term we're going to learn is face. A face is going to be any one of the flat surfaces on our tetrahedron or our polygon. So how many faces does this polygon have? It has 4, because there's 4 flat faces located on the polyhedron. The next one is going to be edge. And the edge, if you think like a knife edge, that's going to be your long straight lines which run along here. There's 1 edge, 2 edge, 3 edge, 4 edge, and 5 edges. So did I count that right? Let's see, 1, 2, 3, 4, 5. Yep, so you have a total of 5 edges that go in that polyhedron. And the third term we're going to learn is vertex. The vertex is the sharp pointy part that you don't want to get poked in the eye with. So we have 1, 2, 3, 4 vertices or vertexes located on our polyhedron. If we jump back over to our assignment page, which is right here, my student pages, this is the instructions, which that's not the size of the envelope we use, but that's okay. It works with any size envelope. And then from there, we can take and move down. It says to introduce the terms of, that says that you got 4 faces, 4 vertices, and 6 edges. Do we have 6 edges? 1, 2, 3, 4, 5. Oh, it does have 6 edges. I missed one. So there is 6 edges on this one. And with that, we have our vocab terms. Now, the envelope itself was what we call a net. Where it was opened up flat, that is going to be a 2-dimensional object. Actually, not quite it isn't, but a net is going to be a 2-dimensional object of a 2-dimensional representation of a 3-dimensional object. And if we were to take and cut this envelope, let's jump over screens again. If we were to take and cut the envelope along some of the lines, so I could take and cut it, and there's lots of ways I could do this, but let's say that I was to cut it this way. Alright, it's cut on that side, and then if I was to take and cut it down this line right here, and then if I was to take and cut it down this line right here, at that point my envelope that was shaped like this is going to take, or my tetrahedron is going to take and lay out flat like that. And you can see you've got the 3 sides that fold back up, or 4 sides that fold back up to go back into the tetrahedron. So the flat part is going to be your net. When you unfold the 3-dimensional object into a 2-dimensional object, that 2-dimensional object is going to be the net. Now, this gives you a clue to answer the question that they have down here. Of those objects, which were those 2-dimensional drawings, which one can be drawn into a net or folded into a net? Well, I already showed you. That's going to, of course, be answer C. Now, there's other ways that you can cut it up to do it. There's more than one way. That was just one way I unfolded it to make it work. There are other ways I could have cut that tetrahedron up and unfolded it flat, and it still would have folded up to make a net, but none of those other ways are represented in the image. So what are you guys going to do from here? You are going to start working on creating nets for a cube. And there's a lot of different nets that you can make for a cube. You've got to see how many of those ways you can discover, and then when you're doing that, you're going to take, and we're not necessarily going to hang them on the wall like they said we're going to, but you're going to be drawing them on a sheet of paper, not necessarily this sheet of paper, but you're going to draw them out on a sheet of paper and turn that in as proof of how many you came up with. Now, there's things I'm looking for. The I'm looking for a solid answer for question number 3, and I'm looking for you to explain to me how many faces are going to be on that cube, how many edges are going to be on that cube, and how many vertices are going to be on that cube. So you've got to create a bunch of different nets, figure out how many different ways you can actually do it, and then fold them up, make sure they work, list the faces, edges, and vertices, and that's all there is to it. This sounds easy. It's not. It's going to really stress your brain coming up with how many there are. Give you a hint. There's more than 10 different ways that you can do this. Good luck. I look forward to seeing what you come up with.